Hello everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Further Mathematics Paper 2, which is the Further Pure Mathematics 2 for October-November 2023, and the code is 9231/21. Okay, just for your information, the content of this paper is same as 9231/23. That means the variant 3 paper. Alright, so please subscribe to this channel if you enjoy watching my video, and share this with your friends. And also, to show support to this channel, you can just click the thanks button below the video. Okay, thank you everyone, and let's move on to question number 1. Okay, so for question number 1, show that the systems of equations, so these are the 3 equations, where k is a constant, does not have a unique solution. So this is the first part of the question, and interpret this situation geometrically. Alright, so now, to show that it does not have unique solution, basically we need to prove the determinant is equal to 0. Okay, the determinant of the matrix equals to 0. Alright, so now first of all, I need to get the matrix. So matrix is basically the coefficients of all the variables. So now I will just write determinant of 14 minus 4, 6. This is the first row. Second row will be 1x, 1y, kz, so 1, 1k. And then the third row will be minus 21, 6, and minus 9. Then, now we need to calculate and show that the determinant equals to 0. Okay, so from here, I will fix the first row. So when I fix the first row, I need to label the sign, plus, minus, plus. And then I consider the columns. So start with column 1. So obviously the cross out is 14 and the sign is plus. So I will write here 14, then the determinant of remaining terms, 1k, 6 minus 9. Okay, then now consider the second column. So the cross out is minus 4 and the sign is minus. So I will write here minus of minus 4. Then determinant remaining terms minus 1, negative 21, and then k and minus 9, followed by plus, which is the next column. So now I fix the third column, and then the cross out is 6. So from here I will write plus 6, then the determinant of the remaining terms, 1 minus 21, 1 and 6. Okay, so now need to calculate the determinant of 2 by 2 matrix. So 2 by 2 matrix is basically cross multiplication. So the orange arrow minus the green arrow. Use the same method for all. Okay, then from here I will get 1 times minus 9 minus 6 times k. Minus minus 4 is plus 4. Then followed by 1 times minus 9 minus k times negative 21. And the last one is 6 times 1 times 6 minus 1 times minus 21. Okay, then from here, basically I'm getting 14 minus 9 minus 6k plus 4 times minus 9 plus 21k, then plus 6 times 6 plus 21. Okay, so when you do expansion, right, so just expand for all. I will be getting first term as minus 126, then minus 84k. Now my third term, 4 times minus 9 is minus 36, 4 times 21k is plus 84k. Then 6 times 6 is basically 36. 6 times 21, 126. Okay, so from here, now first term and last term will be cancelled off. Okay, then the second term will be cancelled off with the fourth term. Then you will get minus 36 plus 6. Sorry, minus 36 plus 36. Therefore, you get 0. Alright, so just write here, since the determinant of matrix equals to 0 is 0, right? The system of equations does not have a unique solution. Okay, now done for the first part. Second part, interpret this situation geometrically. So I need to copy these three equations. So I will get 14x minus 4y plus 6z equals to 5. Then x plus y plus kz equals to 3. And then lastly, minus 21x plus 6y minus 9z equals to 14. Okay, so now from here, first equation I will divide by 2, okay, because I realize that it can be, for the left hand side, it can be divided by 2. So I divide by 2 first. So I'll get 7x minus 2y plus 3z equals to 2.5. That's my first equation. Then my second equation, I will just remain. Then my third equation, I have 21, 6, and minus 9. Then I know that all these are the factors, all these are the multiples of 3. So I divide by 3 first. So I'll get minus 7x plus 2y minus 3z equals to 14 over 3. This is my third equation. So from here, when you look at the first and third, the coefficients, okay, or probably here 7 positive, negative, negative, positive. So probably here I divide by negative 3. Then you can see clearly. So here I divide by negative 3. That means the first one is positive, the second is negative, right? So first one positive, second is negative, and then minus 9 divided by minus 3 is positive 3. Then here is minus. So now you can see clearly that the first and third equation having the same coefficients, exactly the same. Alright, that means there will be parallel, but it will not be identical because the right side is not the same. It's different. Okay, so from here I can say that first and third show two non-identical parallel planes. Okay, and then the second equation is basically non-parallel plane because the coefficients are different, 1, 1, and k. So, and second equation, right, shows non-parallel plane. Alright, so that is the geometrical interpretation of the equations. Okay, now for question number 2, find the roots of the equation, giving your answers in the form of r cos theta plus I of r sin theta minus 5, where the r is greater than 0 and the theta is between 0 and 2 pi. Okay, so now I will find the modulus and argument and principal argument for 4 plus 4 square root 3i first. Right, so the modulus, I would say this is modulus. So modulus of the complex number is basically square root of real squared plus imaginary squared. Therefore, you will be getting square root of 16 plus 48. This is 64. Therefore, square root of 64, I get 8. Okay, now for the argument, principal argument, draw the Argand diagram. Your real part is 4. Imaginary part is positive 4 square root 3. So let's say this is the value and this is the complex number. Alright, so now your principal argument is this angle. So from here, theta is basically inverse tangent imaginary part over real part, because this is your height, 4 square root 3. And then the horizontal distance is 4 units. So then from here, I will get 4 square root 3 over 4. And then here is going to be inverse tangent square root 3. So inverse tangent square root 3 is basically pi over 3. Okay, so from here I will write my complex number in the polar form. That is 8 cos pi over 3 plus I sine pi over 3. This is the polar form. Okay, now to solve this problem, right, I will start with z plus 5i cubed equals to 4 plus 4 root 3i. Okay, then from here, to solve the roots means that you need to find out the z, because in this equation you have the unknown z. Alright, that is the root. So that means now to get this, I will write this is basically 8 times cos pi over 3 plus I sine pi over 3. But to get cube roots later on, when I move this 3 to the other side, I will have to generate 3z value, which means, right, I need to consider the angle. We know that cos and sine, the fundamental period is 2k pi or 2p pi. That's why you can just write pi over 3 plus 2p pi. Okay, I add this because I need to find more than one root. So then from here, your p will be 0, 1, 2, 3. Sorry, 0, 1, 2, because that is the cube root. Okay, power 3 here. So now I will write z plus 5i. The cube move to the other side. That means it will be the cube roots of everything. So, cube roots of everything. Alright. So again, your p value will be 0, 1, 2. So it will be 3 p values because of cube root. Okay, so now you bring the 1 over 3, the power 1 over 3 into 8 and also into the whole cos and sine. So I will get 8 to the power 1 over 3. Then now according to the De Moivre's theorem, okay, so this 1 over 3, you can just times it to the angle there. So it will be cos pi over 3 plus 2p pi over 3. Because you times 1 over 3 means that it is the same as divide by 3. Then plus I sine pi over 3 plus 2p pi, then divided by 3. Okay, so 8 to the power of 1 over 3 is basically 2. So here I can just direct solve. This is basically 2. Okay, so now we can calculate the z plus 5i for p equals to 0, 1, 2. Right, so from here, I will just write when p equals to 0, my purpose is to get the z, which means this 5i, positive 5i, will be moved to the other side. Okay, so then I will write minus 5i plus 2 of cos. So when my p equals to 0, you will get pi over 3 divided by 3. That is pi over 9. Then plus I sine pi over 9. Okay, let's check the question first. The question just say give your answer in this form. Okay, r cos theta plus I sine, r sine theta minus 5. Okay, so from here, I have to expand. This is going to be, okay, look at here, r cos that I. So I will do expansion. These two times in, then I will get 2 cos pi over 9, okay, plus I. Follow the pattern, the form here, r sine theta minus 5. So it means that this pi minus 5, okay, combined with 2 sine, right, pi over 9. So it means that it will be 2 sine pi over 9 minus 5, because it's requested, okay, r sine theta minus 5 over here. So that is the first z value. When p equals to 1, use the same method, minus 5i plus 2 of, okay, so you replace the p by 1 here. So when you replace the p by 1, this is basically pi over 3 plus 2 pi. Then divided by 3, you will get 7 over 9 pi. So here I will just write cos 7 over 9 pi plus I sine 7 over 9 pi. And then now just rearrange 2 cos 7 over 9 pi plus I, then bring in the 2. So I will get 2 sine 7 over 9 pi. Don't forget the minus 5, first term. Okay, now same goes to the last p value, which is p equals to 2. Your z is minus 5i plus 2 times cos. Okay, so you replace it here. So this p will be replaced by 2. You get 4 pi. Pi over 3 plus 4 pi, then divided by 3. That is 13 over 9 pi. Then plus I sine 13 over 9 pi. And now rearrange, you will get 2 cos 13 over 9 pi plus I, then 2 sine 13 over 9 pi followed by minus 5. So that's the solution of this question. Okay, now for question number 3, find the first 3 terms in Maclaurin series for inverse hyperbolic tangent half exponential x in the form of half ln a plus bx plus cx squared, giving the exact values of the constants. Okay, so now I will let fx equals to inverse hyperbolic tangent 1 over 2 ex. Right, so now firstly get f0. So f0 I will get inverse hyperbolic half e0. Half e0 is basically half, because e0 is 1. Okay, so now in order to get the ln here, right, so refer to the formula list. So inverse hyperbolic tangent x, that is half of ln 1 plus x over 1 minus x, whereby the modulus of x is less than 1. That means now your x is half. So it's okay, because modulus x less than 1 means that your x between minus 1 and 1. Okay, so just replace the x by half, then I will get half ln 1 plus half over 1 minus half. So this is going to be half ln 3 over 2 divided by half. Then you will be getting half ln 3. Okay, so now f prime x, how do we differentiate? Okay, so for your information, differentiation of inverse hyperbolic tangent x, that is 1 over 1 minus x squared. This is the formula in the formula list. But then now you look at here, this is no longer x, this is half ex. Therefore, before I differentiate, I will introduce the substitution. My u will be half ex. Alright, so I will let u equals to half ex. Then from here, I need to get my du dx. So my du dx is basically half ex as well. Okay, or I will say that half ex can be replaced by u. Therefore, my du dx is u. Right? And later on, I need to get dx. What is my dx there? So my dx is basically 1 over u, or probably I will just leave it in this form first. Du dx is half, u is u. Okay, so now my fx, okay, so now from here, my fu, because I let my u be half ex, so I will be getting fu instead of fx. It will be inverse hyperbolic tangent u, right? Then from here, now you check, you can compare. They are in similar form, because this is inverse hyperbolic tangent u. This is inverse hyperbolic tangent x, right? So when I differentiate, I will just replace the x here by u. That means now I will differentiate my f with respect to u. That is 1 over 1 minus u squared, according to this formula. Okay, now, but then our purpose is to get df dx, right? Therefore, using the chain rule, so df over dx that is df over du times du over dx. Okay, so now df du is 1 over 1 minus u squared. And then the du dx is given, which is u. Alright, so now I will get u over 1 minus u squared. And now I will change back. My u is basically half ex. So that means now my df over dx is basically half ex divided by 1 minus square of half ex. So it will be 1 over 4 e to x. Right? Just for information, half ex squared, that is half square ex squared. So this is going to be 1 over 4. Ex squared is basically e to x. Right, this is how I get it. Then from here, I can simplify. Right? So then you can just say, because when you look at the the given answer here, you need to differentiate until second derivative. So this is just my first derivative. That means now I need to simplify. Okay, so probably I just write here. Then I simplify it into a simpler form, that is half ex over, I make it as the same denominator, so 4 minus e to x over 4. So the 4 I move up. Alright, so this is going to be half ex multiplied with 4 over 4 minus e to x. So the half and 4 cancel off. Then you are getting 2ex over 4 minus e to x. So you may use this form for the next differentiation. So this half and 4 cancel off. Alright, so now don't forget to find the value. So f prime 0. Okay, f prime 0, it will be 2e0 over 4 minus e0. That is 2 over 4. Then I get half. Oh, sorry, the denominator e0 is 1. So it shouldn't be 4 in the denominator. It should be 4 minus 1, which is 2 over 3. Okay, so now find the second derivative. So I will refer to this simplest form. So now my f, my d square f, or you can say that it is f double prime, up to you. So obviously this is the quotient rule, right? So quotient rule is d over dx u over v. It will be v squared in the denominator, vu prime minus uv prime. Therefore now here I will get over square the denominator. Okay, keep the denominator. Differentiate 2ex. Differentiate 2ex is 2ex. Then minus, keep the 2ex, differentiate the denominator. So when you differentiate 4, you get 0. Differentiate minus e to x. Okay, our formula is here. Differentiate e mx plus b. It is rewrite the whole exponential, then differentiate the power of e, which is m. Alright, so here I will rewrite the negative e to x. Differentiate 2x is 2. So this is my differentiation. Okay, so from here, if you want to simplify, you can just take out the e to x, which is in common. Alright, so here I will get 2ex, not e to x. The common term is 2ex. Then write down the rest of the terms. And now this minus multiply with the minus 2. So it will be plus 2e to x. And then you simplify. So I will get minus 1e to x plus 2e to x is plus 1e to x. This is my second derivative. And then now here I will just write f double prime 0. Okay, replace the value. Replace the x by 0. Then I will get 2e0, 4 plus e0 over 4 minus e0 squared. So this is going to be 2 bracket 4 plus 1 is 5 over 3. 4 minus 1 is 3, so 3 squared. So I will be getting 10 over 9. That is my second value. Okay, so now my Maclaurin series. So inverse hyperbolic tangent x, it will be, okay, Maclaurin series formula is fx equals to f prime 0 not f prime 0, f0 plus x times f prime 0 plus x squared over 2 factorial f double prime 0. This is a Maclaurin series. Right, so now just replace. So I will be getting f0 is half ln 3. So here I will write half ln 3 plus the first coefficient 2 over 3 times x plus the next coefficient 10 over 9 times x squared over 2 factorial. Then here is going to be half ln 3 plus 2 over 3x. So 2 factorial is actually 2. So 10 over 9 times half. That is 5 over 9 x squared. Okay, so we have done the Maclaurin series. So which means your A is half, B is 2 over 3, C is 5 over 9. Oh, sorry, A is 3. Okay, half ln A. A is 3. Okay, now let's move on to question number 4. Find the particular solution of this differential equation given that when x goes to 0, y is 2 and dy dx is minus 8. So from here, I will rewrite the differential equation first. Okay, so first of all, let's right side be 0. Then now the auxiliary equation will be m squared plus 2m plus 3 equals to 0. And this quadratic equation cannot be factorized. Therefore, we need to use the quadratic formula. Quadratic formula is ax squared plus bx plus c equals to 0. So the formula is x equals to minus b plus minus square root of b squared minus 4ac over 2a. Then from here, when you apply this formula, first of all, I will write down the coefficients of m squared, and also the constant. Then now apply this formula by changing the x into m. So I will get m equals to minus 2 plus minus square root of 2 squared minus 4 times 1 times 3 over 2 times 1. Then from here, I will get minus 2 plus minus square root of minus 8 over 2. So hence, from here, right, I will split into two terms. Minus 2 over 2 plus minus the square root of 8. Okay, for your info, square root 8 equals to square root of minus 8. Minus 8 is same as square root of minus 1 times square root of 8. Then square root of minus 1 is basically I. Square root of 8, I can split it into square root 4 times square root 2. Okay, therefore, I will be getting 2 square root 2i. So from here, I will just direct write 2 square root 2i over 2. That means I will be getting minus 1 plus minus square root 2i. Okay, so with this, I will just write down my complementary function y equals to, because you are given dy over dx, means your answer will be y in terms of x. So complementary function, you can just write y equals to e negative x times a cos square root 2x plus b sine square root 2x. That is your complementary function. Okay, now I will show it over here for the trial solution to get the particular solution later on. Okay, so now my trial solution or trial solution. Okay, my y, look at the right side. This is a quadratic function, so it will be the general form, which means that is px squared plus qx plus r. So now I differentiate two times. My dy over dx, differentiate px squared is 2px. The qx becomes plus q. And then my second derivative, differentiate 2px is 2p. So let all this be second equation, and the original differential equation be the first equation. So now I substitute second equation into first equation. So now second derivative, 2p, this is my first term, plus 2 dy dx. So 2 of 2px plus q, and then plus 3y. So plus 3 of the quadratic function, then equals to 27x squared. So from here, I will compare the coefficients, right? So now when I compare by comparing the coefficients of x squared. So now for the left hand side, I know that this coefficient, the x squared will be, for the coefficient of x squared will be 3p for the left hand side. So I will write 3p equals to right side is 27. Hence my p is 27 over 3, which is 9. Then I follow by comparing the x. Okay, so for the left hand side, here I will get x, and then the next one is also x, 3q. Right side there is no x, that means it is 0. So here I will get 2 times 2p plus 3 times q equals to 0. Okay, so now p already found, which is 9. Just replace. This is actually 4 times 9. So 4 times 9 plus 3q equals to 0. That means my 3q is negative 36. So my q is negative 12. Then now I compare the constants. Okay, compare the constant. So now the remaining term will be the constants. Here 2p and then 3r. Right? So here I will write 2p plus 3r. Right hand side is 0 because there's no constant. Right, let me check. Oh, I missed out one term. Here is also constant. Right, so it should be 2p plus 2q, and then followed by 3r equals to 0. So my 3r will be minus 2p. P is replaced by 9. Then minus 2q. Q is replaced by minus 12. Then from here you will get 6. Right, minus 18 plus 24. Then your r is going to be 2. So with this, I can write down my particular integral. So my particular integral, y equals to px squared plus qx plus r, means that it will be 9x squared. Q is negative 12, so minus 12x plus 2. Okay, so with this, I will get my general solution. Let me check the space. Okay, a lot of space here. So now my general solution, my y equals to CF, complementary function plus particular integral. Therefore, my y equals to e minus x, a cos square root 2x plus b sine square root 2x plus the quadratic function. Okay, so now when you look at the question here, you are given x and y values. So x0, y is 2. That is for you to find to get the first equation. Because all these additional values are for you to get the a and b. So now I will just replace 2 equals to e0, a cos 0 plus b sine 0. So plus 0, 0 and plus 2. Okay, then here for your info, sine 0 is 0, cos 0 is 1, e0 is 1. So which means I will be getting 2 is 1 times a. So just a, then plus 2. Which means now your a is basically 0. So when my a is 0, I will rewrite my y first before I differentiate. So which means my y is basically 0. So I will just direct write b e minus x sine square root 2x plus 9x squared minus 12x plus 2. Because of a is 0. Okay, so here a is 0. So now, before I substitute the dy dx by minus 8 and the x by 0, I need to differentiate my function, my result, okay, my general solution. So from here, I need to differentiate first. So now, for the dy over dx, okay, for the first part here, exponential times sine. This is basically the products rule. So d over dx uv. This is going to be uv prime plus v u prime. So firstly, I keep the bex as one term, right? I keep bex as u. So I keep the whole term and I differentiate sine. Just for information, to differentiate sine mx plus b. Okay, so differentiate sine, that is cos. Rewrite the mx plus b. Differentiate mx plus b is m. That means now, here you will be getting differentiate sine, you get cos, rewrite the square root 2x. Differentiate square root 2x is square root 2. And then plus, keep the sine. Right? Differentiate be minus x. So for your info, when you differentiate e mx plus b, that is me mx plus b. So the concept is basically you rewrite the whole e and then differentiate mx plus b is m. So then from here, I will be getting minus be minus x. Because when I differentiate negative x, it is negative, right? So then 9x squared becomes 18x minus 12x is negative 12. The plus 2 will be 0. Then from here, replace the x value. Given x is 0, dy dx is minus 8. So here, I will get dy dx equals to minus 8. And then now I will replace. Okay, so I will replace these two values. I will get minus 8 b e0 square root 2 cos 0 plus sine 0 multiply with minus b e0, then plus 18 times 0 is 18, no need to write, therefore minus 12. Okay, and now again e0 is 1. This is 1. Okay, sine 0 is 0. That means this whole term will be 0. That means now, right, left side minus 8. Then first term on the right hand side, it will be b times 1 times square root 2. The cos 0 is 1. Okay, that means the whole term, here whole term is just square root 2b. Okay, then followed by minus 12. Right, so my square root 2b equals to this minus 12 move to the other side is plus. Therefore, minus 8 plus 12 is 4. Then my b is 4 over square root 2. Now this 4 over square root 2 can be simplified into 2 times 2. The 2 can be split into square root 2 and square root 2. Right? Then divided by square root 2. And at last, the square root 2 will be cancelled off. Then you will be getting 2 root 2. That is my b. So my final answer, okay, that is called particular solution. Then just rewrite the solution over here. Okay, just rewrite this solution by replacing the b value. So I will write y equals to be minus x. So it will be y equals to b is 2. So b is 2 square root 2. So 2 square root 2 e minus x. After that, sine square root 2x. Then followed by 9x squared minus 12x plus 2. So that is my solution of this question. Okay, now move on to question number 5. The curve C has parametric equations. X equals to 2 over 3 t to the power 3 over 2 minus 2 t to the power half, which is 2 square root t. And the y is 2t plus 5, where the t is defined from 0 to 3, inclusive 3. Now find the exact length of C. Right, so for your information, exact length of C formula is S equals to integrate square root of dx over dt squared plus dy over dt squared, then dt. This is the formula, which means now we need to find dx dt and dy dt. So I will rewrite my x first. 2 over 3 t to the power of 3 over 2 minus 2 t degree half. So now my dx dt, I will write 2 over 3. You bring down the power of 3 over 2, the power of t. Okay, so when you differentiate, you always bring down the degree. Differentiate x degree n. That is n x degree n minus 1. So here, I will bring down the 3 over 2. Then 3 over 2 minus 1 is half. Then minus, remain the 2. T power half, bring down the half. Then t power half minus 1 is negative half. Then now I simplify. Okay, so obviously 2 cancel off, 3 also cancel off. So I get t power half. Minus, and then the next term, 2 and half cancel, I get t power negative half. Okay, now my y equals to 2t plus 5. That means my dy over dt, it will be 2. Okay, so now I substitute into this formula to get the arc length of C. So I will write length of C, that is integrate square root of dx over dt squared plus dy over dt squared. Then the t from 0 to 3. So now I will write integrate 0 to 3 square root t degree half minus t degree negative half squared, which is for dx dt squared, plus my dy dt is 2, so 2 squared, then dt. Then now I simplify. So for your information, a minus b squared is a squared minus 2ab plus b squared. Okay, so when you square of t degree half, you square it, it is t degree 1, because our formula is a to the power of m, then another degree outside n. So here will be a power mn. So 2 times half is basically 1. Therefore, here I will just write t minus 2 times t half and t degree negative half. Okay, so here t half times t degree negative half. This is another formula, which is a degree m times a degree n. That is a degree m plus n. So I plus. So half plus minus half. That is t degree 0. T degree 0, you get 1. That's why here, the second term, I will just get 2. Because of this formula, the 2 here. Alright, then plus t power negative half. Then you square it. So again, the negative half times 2, it will be negative 1. So I get t power negative 1. And then plus 4 dt. Then from here, I will get 0 to 3 square root of t minus 2 plus 4 is plus 2 plus t degree negative 1. Okay, so from here, I will say that this is same as 0 to 3. Now you check here. Alright, so if you need to get, but basically you compare these two. Compare these two first with this. The difference is the minus 2 change to plus 2. So when the minus 2 change to plus 2 means that I have to change this minus to plus, because you get it from the square of this difference. Alright, so now becomes square root of t half plus t negative half. Then you square it and dt. Okay, so then from here, the square and square root will be cancelled off. Then I am solving integration from 0 to 3 t degree half plus t degree negative half. Okay, so then very simple. When you integrate t degree n or x degree, I will give you this formula. X degree n dx, this is just x degree n plus 1 over n plus 1, then plus c. But of course here we don't have plus c because you are given the limits. So here I get t degree half plus 1 is 3 over 2. So divide by 3 over 2 plus t degree negative half plus 1 is half. Then divided by half. And with limits 0 to 3. So now, simplify first. This is basically 1 over 3 over 2. 1 divided by 3 over 2, that is 2 over 3. Okay, so I'll change to 2 over 3. T degree 3 over 2. And then 1 divided by half is basically 2. So plus 2 t degree half. 0 to 3. And now just replace. So I will get 2 over 3. This t degree 3 over 2 is basically 3 degree 3 over 2. 3 over 2 is basically 3 square root 3. Okay. Then plus 2, this is square root t. So square root 3. Then minus, when the t is 0, everything is 0. Then from here, since the question asks for exact value, right, I will just give my answer in square root form. So here will be 2 square root 3 plus 2 square root 3. At last, you are getting 4 square root 3. So that is the exact length. Okay, part B. Find the sets of t values for which the second derivative is greater than 0. So now here, I need to write down my first derivative. Okay, so we have found the dx dt is this. T degree half minus t degree negative half. So I will write down first my dx dt equals to t degree half minus t degree negative half. This is basically square root t minus 1 over square root t. Right? So then probably I will just make it to the same denominator. So it means that the first term you need to times square root t over square root t. So square root t times square root t is basically t. This is my dx dt. And then my dy dt from previous calculation, that is 2. Before we get the second derivative, we need to find the first derivative. So I will get it by using chain rule. dy dx is dy dt times dt over dx. So for your info, dt over dx equals to 1 over dx over dt. So which means here, this is 2, I times, okay, times dx, dt dx. So I need to invert this, right? So that means it's square root t over t minus 1, based on this concept. So now I rewrite, this is basically 2 square root t over t minus 1. Now, to get the second derivative, okay, since your dy dx in terms of t, that means I should differentiate the dy dx with respect to t, because your dy dx in terms of t. So when I differentiate this with respect to t, I need to apply the quotient rule. So d over dx, u over v. That is over v squared, vu prime minus uv prime. Okay, so now I will write down my u and v first. So u equals to 2 square root 3, 2 square root t. So my u prime, this is basically 2t power half. So when I differentiate, I keep the 2, bring down the half, t power negative half. Okay, that means this is going to be 2 and half cancel. So t power negative half is basically 1 over square root t. Then my v is t minus 1. So v prime is 1. Okay, so now use these results and substitute it into the quotient rule. I will be getting over v squared. So t minus 1 squared. Keep the t minus 1. And then differentiate the u is 1 over square root t. Minus, keep the u, 2 square root t. And then v prime is 1. Then from here, I simplify it. Okay, so I notice that I have a denominator square root t. So I have to factorize this in order to simplify. So I will factorize 1 over square root t from the numerator. I will get t minus 1. Now, when you need to factorize 1 over square root t from this square root t, basically you are dividing this 2 square root t by 1 over square root t. That means you are getting minus 2t. Because t over square root t is square root t. Then over t minus 1 squared. Just keep this. And then now this whole term can be brought down and combined with the denominator. Alright, then now for the numerator, I will get t minus 2t, which is minus t, and then minus 1 over square root t times t minus 1 squared. So you can keep it in this form, or numerator, you can just factorize a minus because the minus is in common. This is my d over dt of dy dx. And now I need to get d square x, d square y over dx squared. This is going to be differentiate the dy over dx, supposedly with respect to x, but then now your dy dx in terms of t. Therefore, you differentiate with respect to t, and now I don't want the t, I want the x. Therefore, times dt over dx. Right. So now here, just copy the whole term, negative t plus 1 over square root t times t minus 1 squared. Multiply with dt dx. So the dt dx we already solved here. See here, dt dx is basically this term. So square root t over t minus 1. Right, so I will just write here times square root t over t minus 1. Okay. Then now the square root t can be cancelled off. Okay, so these two terms combine, then I will be getting equals to negative of t plus 1 over t minus 1 cubed. And now we are solving the second derivative greater than 0. So d squared y over dx squared greater than 0. That means negative of t plus 1 over t minus 1 cubed greater than 0. But there is a negative here. So when you divide the whole inequality by negative 1, you should change the inequality sign, which means now we are solving t plus 1 over t minus 1 cubed less than 0. Okay, so to solve this inequality, we need to draw the number line. Okay, I will let the numerator and denominator be more than 0 first. So it will be let t plus 1 be more than 0. Okay, t minus 1 cube be more than 0. So then from here, t is greater than minus 1. So when you move the cube to the other side, it is still t minus 1 more than 0. That means I will get t greater than 1. Okay, so now here, I will just draw the number line. Okay, I have two t values, minus 1 and 1. Right, so greater than minus 1 means that the line is towards the right side. This is t greater than minus 1. And then t more than 1 means that it will be on the right side. Now, I let it be more than 0. Therefore, I will label the values on the line as positive, not on the line as minus. So now when you times, right, minus minus is minus, minus plus is plus, plus times plus is plus. Final answer, we refer to this inequality, which is less than 0. So which means, right? Oh, sorry, I overlooked. Minus plus is minus. Minus minus is plus. Right, you times. Minus times minus is a plus. Minus times plus is a minus. So because of less than 0 here, our answer is between minus 1 and 1. Right? So here, supposedly, I get minus 1 and 1 from the number line. Now, you look at the question carefully. Go back to the question. Your t is defined from 0 to 3. Okay? So now, when it is from 0 to 3, so given the t is defined from 0 to 3, So that means we have to accept from 0 to 1, because the minus 1 from 0 to negative 1, it is not defined for the x and y, right? So therefore, the t will be between 0 and 1. So ignore this part. I mean, ignore, it will be like this, something like this. So here, probably you add on the 0 here. So this part will be ignored. Okay, because it does not define for the x and y. Alright, so that's the solution of this question. Okay, now for question number 6a, starting from the definitions of cos and sine in terms of exponentials, prove this identity. So we know that sine x is half of ex minus e minus x. Cos x, it will be half of ex plus e minus x. So I will start from the right side. So 2 sine x cos x, it will be 2 of the sine x is half ex minus e minus x times with another half. Right, probably I close bracket here first. Then times with half of ex plus e minus x. So from here, the 2 and half can be cancelled off. This half, I will bring it to the front. So that means it will be half. Now, ex minus e negative x times ex plus e minus x. Okay, this multiplication of two terms, I can use the difference of squares. A minus b times a plus b. That is going to be a squared minus b squared. So then I will be getting half of ex squared, that is my a, minus e minus x, and you square it. Okay, and then we have formula a to the power of m, that another degree n outside. It will be a degree mn. So I will just times the 2 with the x, that is e to x, minus e negative 2x. Now, when you compare with the sine, okay, you see here, half, here is half, e to x, here is ex, and then minus e negative, right? That means the x here has been changed to 2x. So therefore, I have to change my x in the sine x into 2x. Alright, so which means this is going to be sine 2x. So I have shown the identity. Okay, now B, using the substitution u equals to sine x, find this integration. So I will write u is sine x first. So now you need to get du dx. So du dx, to differentiate hyperbolic sine x, that is hyperbolic cos x. Alright, then from here, I will write my d, you see here, cos x dx. My du is cos x dx. Therefore, my integration, sine square 2x, sine square 2x, cos x dx. So this sine square 2x, I can change to square of sine 2x, then cos x dx. Now, before I replace my u is sine x, right? My sine 2x here, sine 2x, I will change it to 2 sine x cos x, right? So replace first. So here is going to be 2 sine x cos x, you square it, then another cos x dx. Now, bring in the 2, 2 squared will be 4. So I will factorize the 4. Then I will get sine square x, cos square x together with the cos x. Right? I will not combine because I know that my cos x dx is du. So I need to keep this and change to du. So therefore, my cos square x as one term. Then after that, cos x dx. Alright. Now, since your u is sine x, okay, so now I need to change my cos square x here into sine x. So we have an identity. Sine, okay, for the trigon identity, sine square x plus cos square x equals to 1. If you convert it to hyperbolic, right, so I add on the h here. That means I add on the h here. So I add on the h. The sine one will be negative. Right? That is my new formula. This is my hyperbolic identity. And then now I need to get what is my cos square x. So this negative sine square x will be moved to the other side. That means cos square x is 1 plus sine square x. So this is going to be 4 integrate sine square x. So the cos square x is 1 plus sine square x. Then after that, cos x dx. So here is going to be 4 integrate u squared bracket 1 plus u squared, and the cos x dx is to be replaced by du. Okay, so here I will change it to du. And now for this integration, before we integrate, the u squared must be times into the whole bracket. So here is going to be 4 integrate u squared plus u degree 4 du. And now here I will be getting u cubed over 3. Okay. And then the u degree 4 becomes u degree 5 over 5, followed by plus c. Then from here, you just replace back because we know that our u is sine x. So u degree 3 is basically sine cube x. Then this 4, you times into the 1 over 5, that is 4 over 5. Okay, you can just times in or you can leave it outside, it's up to you. So 4 over 5 sine degree 5x followed by plus c. So this is your integration. Okay, now part C. Find the particular solution of the differential equation given that y equals to 4 when x equals to 0, and give your answer in y equals to fx form. So now dy over dx plus y inverse tangent x equals to sine square 2x. Okay, so now from here, I need to apply the integrating factor method. So let's say this is the first equation. My integrating factor I is E integrate hyperbolic tangent x dx, because the general formula is basically dy over dx plus ypx equals to qx. So your integrating factor is E integrate px. Alright. So then when you integrate tangent, hyperbolic tangent, this is E integrate sine x over cos x. This is going to be E. Now, when you differentiate cos, it is sine. Therefore, this is ln. Okay, so E ln cos is just cos x. And let this be second equation. So now I will times the second equation into the first equation. So if you are confirmed that your I is correct, once you times the left hand side is supposed to be two terms, by default it will be d over dx yi. So since I'm confirmed that my I is correct, I will just write y cos x. Okay, right hand side you need to times, so it will be cos x times sine squared 2x. Now to get the solution, right, differentiate y cos x equals to right side, which means y cos x equals to integration of cos x sine squared 2x. Okay, this integration we have solved it in the previous part. Right, cos x times sine squared 2x, which is here. That means I will just copy the answer, this result, right? 4 over 3 sine cube. So here it will be 4 over 3 sine cube x plus 4 over 5 sine degree 5x. Then plus c. And now, replace the x by 0, y by 4. So x by 0, y by 4. So then you will get 4 cos 0 equals to 4 over 3 sine 0 cube. I will take out the degree 3 plus 4 over 5 sine 0 degree 5 plus c. Okay, for your information, cos 0 is 1. Sine 0 is 0. That means now obviously your c is 4. Okay, so c equals to 4. Then now I just substitute back this result into your solution. So my y cos x, it will be 4 over 3 sine cube x plus 4 over 5 sine degree 5x plus 4. But when you look at the question, y equals to fx. Therefore, I have to move down the cos x. So that means I divide the whole equation by cos x. So divide by cos x means that is hyperbolic second, alright? Divide 1 over cos is basically hyperbolic second. So I will just write my y is basically, okay, take out the 4 from both sides. 4 hyperbolic second x multiplied with 1 over 3 sine cube x plus 4 plus 1 over 5, because the 4 is taken out. 1 over 5 sine degree 5x, then plus 1. Okay, because I factorize the 4. So probably from here I will just write this is 4 bracket 1 over 3 sine cube x plus 1 over 5 sine degree 5x, then I plus 1. Then you can see clearly. Okay, so that's all for this solution. Okay, now next question is question 7. Given this matrix A, first part, find the matrix P and D such that A inverse is PD P inverse. Okay, basically, we are getting A equals to PD P inverse. Alright, D is a diagonal matrix that consists of eigenvalues. Eigenvalues, yes, eigenvalues. And then P is the corresponding matrix, the matrix that consists of corresponding eigenvectors. Okay, this is the general formula. Alright, but now when you look at here, your A has been changed to A inverse. Alright, so then now we have to find the D first. So the matrix D, alright, I will write the determinant of A minus lambda I equals to 0. So it is same as this. Negative 6, 0, 0, 2 minus 2, 0, 13, 5, 8. This is a matrix. You minus lambda of the identity matrix. and then equals to 0. So that means this is same as, let me check the space. Okay. That means this is same as determinant of minus 6 minus lambda. Okay, then 2, 13. The second value is 0. Then minus 2 here. Okay, minus 2 minus lambda. So the diagonal, you have to minus lambda. So minus 2 minus lambda, then 5, followed by 0, 0, 8 minus lambda. Then now, to get the lambda value, which is our eigenvalues, I will fix the first column, because in that column there are 2 zeros. So I fix this column, and then now I label the sign. So the first one is plus, the second is minus, the third one is plus. So basically we can ignore the second and third. Right, so now you consider the first column, sorry, first row, because this one I fixed the first column. Now consider first row. So I will get the cross out of minus 6 minus lambda. So I will get here minus 6 minus lambda, and then the plus sign, and the remaining terms will be minus 2 minus lambda, 0, 5, 8 minus lambda. This is 2 by 2 determinant. And now to solve the 2 by 2 determinant, use cross multiplication. So the orange arrow minus the green arrow. Okay, then you will be getting 3 lambda values. That will be our eigenvalues. Orange value, okay, orange arrow, 0 times 5 minus 2 minus lambda times 8 minus lambda. So basically the first one will be 0. Okay, so here this minus I can just times into the first bracket. So which means I'm getting minus 6 minus lambda bracket 2 plus lambda, then 8 minus lambda equals to 0. So the multiplication of these three values equals to 0 means that one of them must be 0. Okay, so it means that minus 6 minus lambda equals to 0, or 2 plus lambda equals to 0, or 8 minus lambda equals to 0. So that means you are getting lambda equals to minus 6. Let's say this is first lambda, second lambda is minus 2, and third lambda is 8. So with these 3 lambda values, 3 eigenvalues, I need to find 3 eigenvectors. Okay, so then now here, I will start with first eigenvector. When lambda equals to lambda 1 equals to minus 6, right? So a minus lambda I times x equals to 0. So just now a minus lambda I determinant. This is basically my a minus lambda I. This, when I put this whole matrix, I add the bracket matrix to becomes a matrix. This is my a minus lambda I matrix. Okay, if I change the straight lines into brackets, that is my vector. That's my matrix. So what I need to do is I will just refer to this matrix and change my lambda into minus 6. Right. So when I change to minus 6, the first one will be 0. Okay, so 0 to 13. So I will get that matrix 0 to 13. Then my second row, when you change a minus lambda in the lambda, you change the lambda into minus 6. So I will get minus 2 plus 6, that is 4. So I will get 0, 4, 5. Okay, and then the last row, this lambda replaced by minus 6, so that is 14, 0, 0, 14. And then the x will have 3 components. This is 3 by 1 matrix or 3 by 1 vector. Then here will be all zeros. And now to find the eigenvector, I will just solve the x, y, z. Okay, so then from here I will get 14z equals to 0 from the last row. That means my z is 0. Then for the second or third first or second equation, right, I will get the same result. So probably I will just write 2y, okay, from the first equation here. It will be 2y plus 13z, but since your z is 0, that means it will be 0 on the right side when you do expansion. So therefore my y equals to 0. So now you only have two values, right? Then my x will be any other numbers because the coefficient for x is 0. So that means from here I will be getting xyz equals to t 0 0. Then I will factorize the t to get 1 0 0. So then I will be getting my first eigenvector, that is 1 0 0. E1. Okay, now I will continue this with my next lambda. Probably I'll do it here. Okay, I continue here because later I need to find the D. I'm scared of not enough space. Okay, so I will just continue this side. So I'll continue here. Alright, so now my lambda is minus 2. So when lambda 2 is minus 2, alright, so now replace the lambda by minus 2 in this matrix. Use the same method, you will be getting minus 4, 2, 13. Then the second column, second row 0, 0, 55. Sorry, 0, 0, 5. And then 0, 0, 10. Then here x, y, z equals to all 0. Okay, so now I refer to the second row. I'll get 5z equals to 0. Hence my z is 0. Third row will be the same result. So first row minus 4x plus 2y. The z already 0, no need to write. So from here, I know that my y equals to 2x. I just let my x be u. That means my y equals to 2u. Then I will get my result. X is u, y is 2u, z is 0. So from here, you take out the u, 1, 2, 0. That is your E2. Okay, and now for the last lambda. So when lambda 3 equals to 8, that means the corresponding matrix will be minus 14, 2, 13, 0, minus 10, 5, then 0, 0, 0. Then I will get x, y, z equals to all 0. Okay, then from here, right, you will be getting minus 14x plus 2y plus 3z equals to 0. Then the next equation, because minus 5 and 10, I will get minus 10 and 5. Minus 10y plus 5z equals to 0. Then now from here, I can say that my 5z, okay, so from here, 5z equals to 10y, so the z equals to 2y. So now, since your z equals to 2y, I will let y be s, right? Because you only have two equations but three unknown. Therefore, you must get infinite solution. So then from here, my z will be 2s. So then, when you substitute these two results into the first equation, I'll get minus 14x. So the 14x I will move to the other side. So 14x equals to 2y plus 3z. Z is replaced by 2s. Therefore, from here you will be getting 28s. So x and your x will be 2s. So then rewrite the solution. So x is 2s, your y is 1s, z is 2s. Then now take out the s, 212. Then from here I get my E3 equals to 212. Okay, so now I can write down for A, right? For A equals to PD P inverse. Okay, then now you are given A degree -1. So we have a formula. If here A degree n, this is degree n. So when A degree 1 equals to PD P inverse, that means now this D, let's say this is my D1. This D is my D1 degree -1. Okay, so I will write my D1 as the matrix that consists of the lambda value -6, -2, and 8. So here is going to be -6, -2, and 8. But then degree of -1. So when it is diagonal matrix, this -1 you can just bring in will be the power of all the diagonal values. So this is -6 degree -1, 0, 0, 0, -2 degree -1, 0, 0, 0, 8 degree -1. Okay, then here I will be getting -1/6, 0, 0, 0. This is -half, and then 0, 0, 1/8. This will be my D. Then together with the P will be all the eigenvalue, all the eigenvectors. So I will copy 1, 0, 0. And then the other one is 1, 2, 0 followed by 2, 1, 2. So 1, 2, 0 followed by 2, 1, 2. That will be my matrix P. Okay, so done for this question. Okay, now B, use the characteristic equation of A to find A inverse. So now we will start with determinant of A minus lambda I equals to 0 first. So then from here, your A is A minus lambda I. Okay, so just copy back these three equations, these three terms. So -6 minus lambda multiply with -2 minus lambda, 8 minus lambda equals to 0. Okay, so then from here, I'll do expansion. It will be, okay, now for the first two brackets, because you can factorize minus, so I get 6 plus lambda, then 2 plus lambda, 8 minus lambda equals to 0. So when you do expansion, 12 plus 8 lambda plus lambda squared, then multiply with 8 minus lambda equals to 0. So when you do expansion, I'll get 96 minus 12 lambda plus 64 lambda minus 8 lambda squared plus 8 lambda squared minus lambda cubed equals to 0. Then from here, basically, you are getting minus lambda cubed plus 52 lambda plus 96 equals to 0. Okay, now I can just times the whole equation by minus. You will get lambda cubed minus 52 lambda minus 96 equals to 0. And now we need to get A. So just replace the lambda by A. That is A cubed minus 52A minus 96I. I is the identity matrix. Right, now from here to get the A inverse. So to get A inverse, you times the whole equation by A inverse first. So it means that now I will be getting A squared minus 52I. Okay, or probably I just show you step by step. So here you get A squared. A times A inverse is I. Then 96 A inverse equals to 0 matrix. And now you need to get A inverse. So this 96 A inverse move to the other side, it will be A squared minus 52i. So then from here, A inverse is 1 over 96 of A squared minus 52i. Okay, so now what is my A squared? So basically, I will just solve the A squared. A squared, you copy back from this matrix, right? So I will write here, minus 6, 2, 13, 0, minus 2, 5, 0, 0, 8. So you square it. So now you just expand, and at last you will get 36 minus 16, 36, 0, 4, 30, then 0, 0, 64. Okay, then now substitute into this result. So your A inverse is 1 over 96 of this whole matrix minus the identity matrix. Means the diagonal will be 0. The diagonal will be 52. Okay, I write down here. So you minus 52, 0, 0, 0, 52, 0, 0, 0, 52. Okay, so when you minus and divide, basically you are getting negative 1 over 16 after you times by 1 over 96. So minus 1 over 16, 3 over 8, then 0, negative half, 5 over 16, followed by 0, 0, 1 over 8. So that is your inverse matrix. Okay, so done for this question. Now for question number 8. A, state the sum of the series. So basically this is geometric. Alright, A is 1, geometric. The R is Z. And we have n terms here because the first one is Z degree 0. So here 1 to n minus 1 is n minus 1 term together with the first term, that means n terms. So our Sn is A bracket Rn minus 1 over R minus 1. Right, that means here I will get Sn equals to, my A is 1, R is Z, degree n minus 1 over Z minus 1. That is Z degree n minus 1 over Z minus 1. So done for the first part. Now by letting Z equals to cos theta plus I sin theta, show this. Okay, so now what I need to do is, I need to write 1 plus cos theta plus cos 2 theta until cos n minus 1 theta. So this is basically same as, okay, let Z be 1 plus cos theta. So now I will write from the first part, okay, from A. One plus Z squared equals to Z degree n minus 1 over Z minus 1. Okay, so now my Z is cos theta, so means 1 plus cos theta plus I sin theta plus cos theta plus I sin theta squared plus until cos theta plus I sin theta degree n minus 1. This is cos theta plus I sin theta degree n then minus 1 over cos theta plus I sine theta minus 1. Okay, then this is from the De Mor's theorem. I get 1 plus cos theta plus I sine theta plus cos 2 theta plus I sine 2 theta, then plus cos n minus 1 theta plus I sine n minus 1 theta. This is going to be cos n theta plus I sine n theta minus 1 over cos theta minus 1. Okay, that is a real part, plus I sine n theta. Sorry, there's no n, just sine theta. Okay, so now when you look at the question over here, we are just interested to get the cos, right? And not the I. Therefore, this is the real part. So now I need to solve the real and imaginary parts first. So I group all the real part. So this is going to be, for the right hand side, I need to times the conjugate. So cos n theta minus 1, then this is my real part, plus I sine n theta over cos theta minus 1 plus I sine theta, I times the conjugate. Conjugate is cos theta minus 1 minus I sine theta. Okay, so for the right hand side, this is going to be, so when you do expansion, that is cos n theta minus 1 times that, it will be squared, then minus I sine theta, or there is not squared because the first one with n theta, the second one without n theta. Then you get minus I sine theta multiply with cos n theta minus 1, then plus I sine theta n theta multiplied with cos theta minus 1, then minus I squared sine n theta sine theta over complex number times conjugate is basically real part squared plus imaginary part square. Okay, so then from here, this is going to be, now I will just write the real part because we are interested to get the real part. So by considering the real part, so my real part on the left hand side is basically 1 plus cos theta plus cos 2 theta until cos n minus 1 theta. That is my real parts on the right hand side. Okay, so just write down those without the I. So this I square is basically minus 1. So minus minus is a plus. So copy the first and last term. So I will get cos n theta minus 1. Then cos theta minus 1 plus sine n theta over the denominator when you do expansion, cos squared theta minus 2 cos theta plus 1, then plus sine squared theta. And now we need to prove this form. Okay, so from here I will have to write this is same as over cos squared theta plus sin squared theta is 1. Okay, so this is 1. 1 plus 1 is 2. So I will write down 2 bracket 1 minus cos theta because the 2 is in common. Right? So then from here, when you do expansion, okay, let me check. Okay, no need to do expansion, just rewrite this first. Okay, then from here, this is sin n theta. Right, then from here, I can just say this is same as half, take out the half. Then now, this is basically, I will split it into 2 terms. Right, so basically here, probably I will just write, this is basically over 2, 1 minus cos theta. Then here over 2, 1 minus cos theta. Alright, so then when you look at here, this is cos theta minus 1, this 1 minus cos. So when I cancel, I still have the minus outside. Right? Once I factorize a negative. So which means, that means it will be negative. Right? Okay, so I will cancel off that, but when after I factorize negative, so it will be negative of cos n theta minus 1, then plus sin n theta sin theta, then over 1 minus cos theta. Okay, so when you rearrange, that is going to be half 1 minus cos n theta plus sin n theta sin theta over 1 minus cos theta. Okay, so that's the answer for this question. Okay, now for the C, the diagram shows a curve with y equals to cos x, x from 0 to 1, with the set of n in rectangles with width of 1 over n. Consider the sum of the areas of these rectangles. Show this result. Okay, so from here, I will write sum of rectangles. That is 1 over n. Okay, so from here, when you look at this is following the second ordinate. So this is 1 over n. That means the second one here is going to be 2 over n. Okay, or the height. This is going to be, following the first ordinate of the rectangle. This is going to be 1 over n over n. This is a cos. This will be the height. Right? So then from here, I will say that it is 1 over n in common, then cos of the first ordinate of the rectangle. So I will get 1, okay, plus cos 1 over n plus cos 2 over n plus until cos of n minus 1 over n. Then now, when you compare with the previous result, cos theta, 2 theta until n minus 1 theta, that means now your theta is 1 over n. Okay, so that means your theta is 1 over n. So now you just replace. It will be 1 over n of half. So you copy the answer from here. Alright, 1 over 1 minus cos n theta. So here I will write 1 minus cos n theta and then plus sin n theta over 1 minus cos theta. And then now replace back. Your theta is 1 over n. So here I will get the half, take it out, 1 over 2n. So 1 minus cos n times 1 over n plus sine n theta means n times 1 over n. That means that is 1 basically. Okay, so n times 1 over n. Then sine 1 over n over 1 minus cos 1 over n. That means here I will be getting 1 over 2n, 1 minus cos 1 plus sine 1 sine 1 over n over 1 minus cos 1 over n. Okay, so you want to show this, probably you can just write integration from 0 to 1 cos x dx is less than this. Right, therefore here I will just write less for all. So with this I have proven the inequality. Not inequality, proven that the area under the curve is basically less than that. Right, it is exactly the same. Okay, now D, use a similar method to find in terms of n a lower bound for this. So when lower bound, right, which means now my graph no longer like this. I mean my rectangle is different. So just now I refer to the first ordinate of each. Right, now I will refer to second ordinate. That means my first graph is up to here, second graph is here. Okay, so my last graph is here. So that means this value is cos 1 over n. Then the second value here is cos 2 over n. And then the last rectangle, this is cos 1. Okay, so but then the width is still the same. So it means that now when you look at here, obviously my graph will be my integration of the graph will be greater than the sum of the areas of rectangles. Right, so here I will write integration from 0 to 1 cos x dx is greater than sum of the rectangles, sum of the areas. Which is greater than the width is still half n1 over n. So now my first height is cos 1 over n. Okay, then my last height is cos 1. So which means now I will get cos 1 over n plus cos 2 over n plus until cos n minus 1 over n, and then lastly plus cos 1. Okay, and again when you compare this with the theta in part 1, so this is cos theta plus cos 2 theta plus until cos n minus 1 theta. Then I plus cos 1. Okay, where theta is 1 over n. Now you check. I put a bracket for all these terms. Cos theta until cos n minus 1 theta. From first part, see here, cos theta until cos n minus 1 theta is basically this whole term. And then this one I will have to move to the other side, minus 1. Okay, so I will copy this and then minus 1. So then that is only for the bracket the red bracket. So here greater than 1 over n, it will be half of 1 minus cos n theta plus sine n theta over 1 minus cos theta. Okay, as I have mentioned just now, you need to minus 1, right? So close bracket before you minus 1. That all this will be for the red bracket. And then you plus cos 1 at the back. Okay, this will be your working. Now, I need to simplify. Again, my theta is replaced by n 1 over n. So here is greater than 1 over n half. This is 1 minus cos n times 1 over n plus sine n times 1 over n, then sine 1 over n over 1 minus cos 1 over n. Right. Then now you close bracket. So if I don't want to close bracket, I want to consider if I take out half from these two terms. So that means I have to times 2, right? So when I times 2, it becomes minus 2 plus 2 cos 1. Okay, then from here, I will just say this is greater than 1 over 2n. I factorize the half and combine with the n. Okay, and now I simplify. So here is 1, this is minus 2. Right? So 1 minus 2, I get minus 1. But then I don't want to write the minus 1 first. So now from here, probably I can just add one more step. That is, okay, 1 minus 2, I get minus 1. Write down first, never mind. This is cos 1, right? So minus cos 1, then plus sine 1 over n over 1 minus cos 1 over n and plus 2 cos 1. Okay, so look at here, minus cos 1 plus 2 cos 1. Therefore, that is going to be plus cos 1, right? So I continue this side, I continue here. So this is more than 1 over 2n. So 2 cos 1 minus 1 cos 1 is cos 1. Write the minus 1, then rewrite the last term. Okay, so then from here, I will just rewrite. The left side is basically 0 to 1 cos x dx. Since this integration is greater than that, that means the lower bound, because the question is asking for lower bound, right? Find a lower bound for this integration. So it means that I will say the lower bound of the integration is 1 over half n, 1 over 2n cos 1 minus 1 plus sine 1 over n over 1 minus cos 1 over n. Okay, so this is the answer for the lower bound of the integration. Right, so I have done this question and we have come to the end of the video. Thanks for watching. Again, please subscribe to the channel and share this channel with your friends if you enjoy watching my video. And to show support to this video, to show support to this channel, you can just click the thanks button below the video. Okay, stay tuned for more upcoming videos and thank you for your support. See you, bye.